Alright, hello class. Today we're going to be going over two different lessons during our math instruction time. The first lesson that we're going to be going over is a lattice algorithm, and the second lesson is going to be tricks in order to help you multiply by 11 and make it a little bit easier for you. So let's go ahead and just jump right in. Alright, lattice algorithm on the board. I'll give you a little bit of vocabulary. First is, like I said, the lattice algorithm. And what a lattice algorithm is it a little bit different than your typical algorithm, which I'll show you, and I'll write that one down also. And in the lattice algorithm, when you multiply, you're going to have a box with lines drawn across it for each digit that you're going to use, and diagonal lines in it, making it look like a lattice, which is why it is called the lattice algorithm. And you're going to put your numbers here and here, so that when you multiply, it's a little bit more visual and a little bit easier to see the numbers that you're multiplying, where the products come in, and how to add them up. Now, this is different than your typical algorithm, like I said, and the typical algorithm is a scaffold algorithm. And what that is when you have your multiplication numbers, say we're going to multiply 38 and times 85. You have them, excuse me while I get this. You have the numbers up and down stacked on top of each other in a manner with the line on the bottom for your product in a manner like a scaffold. Now, this is kind of hard to do because let's erase this and move this all up a little bit so that we have room to work the problem. Because you're going to have to be adding and dropping place values and things like that. So let's just go ahead and jump right into it. The first numbers that we're going to multiply are 5 because it's in the ones place, and 8 from 38 because it's also in the ones place. 5 times 8 is 40. So what we do is we put the 0 right here, but because you can't put 4 right here because you still have to multiply, you bring the 4 all the way up here. And then you multiply your 5 times the number in the tens place on the first multiplicand. And that is 5 times 3 is 15, but you have to remember that you have this extra 4 tens places here, so you have to add that to the product of 3 and 5, which is 15 plus 4 is going to be 19. And since you're not multiplying by anything else, you can go ahead and put your 1 right here. Now, I'm going to go ahead and show you to multiply by the tens place. And what we're going to do is we're not going to need this 4 anymore. When you do your work, you're going to go ahead and leave it, but there's only so much room, so we're going to go ahead and just erase it for now. What you're going to do is you're going to multiply 8 times 8, and that is 64. But because this number is in the tens place instead of the ones place, there's not going to be anything right here, so we'll just put an X. 8 times 8 is 64, so we'll bring the 4 over here and carry the 6. And then 8 times 3 is 24, and again, you have to add the number that you carried to the product of those two numbers. So 24 plus 6 is 30, and then you would add those two numbers, and see, it starts to get long and you start running out of room. So you're going to add these two together, and you're going to get 0, 4 plus 9 is 13, and again, we have to carry. So carry that up. 0 plus 1 is 2, and 3. So your answer is 3,230. Now, you can get the answer that way as long as you make sure to follow those steps, dropping place values, carrying numbers, but it can be tedious, especially with all of the adding, and when you get into larger numbers, it's going to be a lot harder to add that way. So, let's go ahead and we'll erase this problem that we just did. We have the answer for it right here, and we're going to go ahead and do the same number, but in our lattice algorithm. Okay, so we're going to do, we'll go ahead and do the 8s and the ones places in one color, and the tens places in a different color. So when you multiply with the lattice algorithm, you're going to start at the top or at the bottom. It doesn't matter because you aren't adding anything yet. You're going to start with either one of these numbers, and you're going to multiply that number straight across with the number in this box and the number in this box, and you can go two-digit numbers times five-digit numbers, three-digit numbers times four-digit numbers. It really doesn't matter as long as you draw the box to fit it. So we're gonna start with the ones place like you would do with your typical algorithm, just to make it a little bit easier. So like we said earlier, 8 times 5 is 40. And then 5 times 3 is 15. And 8 times 8 is 8 times 8 is 64. Had a moment there. And then 8 times 3 is 24. So now what you do in the lattice algorithm is you're going to go ahead and start adding. But the way we're going to add is a little bit different. These diagonal lines, and I'll redraw them in green so they're easier to see and they stand out more. These diagonal lines that we have here, they are going to be the key for where you want to add from, okay? So when you're multiplying with the lattice algorithm, what you're going to do is any number from this line to this corner is the ones place. Any numbers in between these lines, when you add them together, is the tens place. And here's the hundreds place. And here's the thousands. And as you get to bigger boxes and bigger numbers, you'll have 10,000, 100,000, millions, and so on and so forth. But we're going to just stick with these numbers. So 0 plus nothing, because that's the only number in the ones place, is going to stay 0. 5 plus 4 is 9, plus another 4 is 13. But again, 13, the 1 is a hundreds place, so you move that up here. 6 and 4 is 10, plus 2 extras is 12. And then you carry that one also up to the hundreds place. And then 3 up to the thousands place, and then 2 plus 1 is 3. And you still come up with 3,230. And you can see every number and where it's going. Let's try another one. The next one that we're going to do, let's go. Let's go 15 and 18. I don't know. 15 times 18. Now we're going to go straight across, add them up, and then write the product over here. And then I'll also show it to you in the scaffold algorithm to see how it works, how it all comes about that way, so that you can get a little bit of both of them. 8 times 5 is 40. 8 times 1 is 8. 1 times 5 is 5, and then 1 times 1 is 1. So we're going to have 0 in the ones place. 8 plus 4 is 8, 9, 10, 11, 12, plus 5 more is 17. And 0 plus 1 plus 1 plus 0 is 2. And then 0 is just 270 for 15 times 18. So let's go ahead and do that in the scaffold algorithm. 15 times 18, 0 like we said, 40, 8, 9, 10, 11, 12, and then again we have to drop the place value because we're now multiplying in the tens place instead of the ones place, and we have 5 times 1 is 5, and 1 times 1 is 1. Add those two numbers together, 0 plus 0 is 0, 2 plus 5 is 7, and 1 plus 1 is 2. Okay, so let's do a bigger number. Let's try a 3-digit times a 2-digit number. For a 2-digit number, let's go ahead and go 126. times 47. Why not? And we'll also write it over here for scaffold algorithm. But we're going to do this one first and then go back to that one because we're already going to see the product, and we're going to make sure that we that we've done it correctly. Okay, so 7 times 6 is 42. 7 times 2 is 14. And 7 times 1 is 7. Ones place, tens place, hundreds place, thousands place, 10,000s place, because like I said, sometimes you're going to get into a little bit bigger numbers. So, 4 times 6 is 24. Oh, I wrote those backwards. 4 times 2 is 8. And 4 times 1 is 4. So let's go ahead and add them up together. Remember, ones place is only this number, so this is always going to be what it is, 2. 4 plus 4 plus 4 is 12, because 4 times 3. 7 plus 2 plus 1, let's go about this a little bit differently. 8 plus 2 is 10, plus 7 is 17, 18, 19. And then 0 plus 4 plus 0 plus 1 is 5. And there's nothing there. So our answer comes out to 5,922. Okay? So let's go ahead and try it this way. 42. 14 plus 4 is 18. 7 plus 1 is 8. Drop in place value. 4 plus 6 is 24. 4 times 2 is 8 plus 2 is 10. I'll go ahead and leave that one there. And 5. 2, 12, 9, 5. Same number. Okay. Now that I think you've got the concept of it down, I'm going to go ahead and pass out a couple of worksheets. One of the worksheets is going to be 2x2s, and one is going to be 2x3s, the big one that we did. I'll be going around to do one-on-one work, and we'll work some of the problems on the board. And then when we're done with that, we will go ahead and move on to the next problem, which is going to be the lattice algorithm, like I said earlier. All right, now that we're back, we're going to go ahead and go to our the next part of our lesson, which is the 11's trick. Oh. And what this is it's a way to make it easier to multiply a two-digit number times the number 11. And I'm going to go ahead and explain why while I show you a few examples, and then we've got a worksheet for this one also that is 11 times a whole bunch of two-digit numbers. It's going to be real fun. So, what the 11's trick is when you multiply any two-digit number times the number 11, so we're going to leave 11 right here. Any two-digit number, it's the same way to figure out how to get the product. So let's give a two-digit number, say, I don't know, 28. No, 27. Okay, so what you're going to do is you're going to take the number in the ones place, and we're going to do it over here, and then we're going to work the problem. We're going to take the number in the ones place and put it over here in the ones place of the answer, because we've got ones, tens, and hundreds. Okay? So the number in the ones place is going to be 7, so we're going to put that in the ones place. And the number that's in the tens place, we're going to put in the hundreds place. And we're going to take the two numbers that are not 11, and we are going to add them together or we're gonna put that in the tens place. Okay, so this is potentially what our product is going to be, and now we're gonna go ahead and multiply the numbers together. Ignore this, ignore that little bit right there, that's still a 2, you guys know that. So we're gonna multiply 7 and 1 is 7, and again 7 and 1 is 7. We're going to drop the place value because again when you multiply a number that's in the tens place, you drop the first number straight down and then work to the left from there. You never put anything in the ones place when you're multiplying by the number in the tens place. So 2 times 1 is 2, and 2 times 1 is 2. So you get the 2 in the tens place and the 2 in the hundreds place. Okay, so what we're going to do now is we're going to go ahead and add those up. 7 and 2 is 9, and 2. Now, see, 297, 297. Now, this is why it works. When you multiply a number by 11, the product is always going to be that number that you started with. So if you multiply a 1-digit number times 11, you're going to get double what that 1-digit number is. Say you multiply 11 times 3, you're going to get 33, because it's 11 3 times 11, 22, 33. That's how you count it up. Now, when you get to multiplying 11 by 2-digit numbers, the reason that it works is because when you multiply by the 2-digit number, you have to have the ones place and the tens place product, the ones place product and the tens place product, and add them together. So our ones place product is 77, 7 would go right there, but then you have the 2 from the tens place right here. 7 and 2 is 9, and then 2 was now in the hundredth place, and it's 297. It's always going to work that way. Let's try another one. And you know, since it's 2 digits and 2 digits, that we're going to have to add, so I'm just going to go ahead and leave that box there. And let's go with 11 times 76. Now this one's going to be a little bit different because 7 and 6 comes out to a 2-digit number itself. So again, take the number in the ones place and put it in the ones place. Take the number in the tens place and put it in the hundreds place. Add them together, and you get 13. But because you can't have a 2-digit number in the tens place, you take this 1 and you move it over and add it to 7. So your total answer, I'm going to go ahead and write it below the box this time, is 836. So let's go ahead and ignore this, ignore those, and multiply. 6 times 1 is 6, 6 times 1 is 6. Drop a place value because you're going to start going straight down. 7 times 1 is 7, 7 times 1 is 7. So you have 6 plus nothing, because this is a 0 now. 6 plus nothing stays 6, 6 plus 7 is 13. And you have to carry the 1 like you would in normal addition. And 7 plus 1 is 8, so you come out with 836, and those two numbers equal each other. Let's go ahead and do a couple more problems. Go ahead and erase that all and I'll rewrite it. Let's go ahead and do 94. 4 times 1 is 4, and 4 times 1 is 4. So 44. Drop your place value, that becomes 0. 9 times 1 is 9, and 9 times 1 is 9. So you have 4. 4 plus 9 is 13. And 1 plus 9 is 10. So you're gonna come up with 1034. So like I said, ones place goes over here. Tens place goes over here. And add them together. That number comes and goes right here. But again, because we came up with a 2-digit number in the tens place, we have to take this digit, move it over to the hundreds place, and now that becomes a 10. And so we have to take this out, and move it over, and make a thousands place. And that's a little bit tricky. I don't expect all these lines and craziness on your papers, but I'll go ahead and again write the numbers down. 1034 is when you multiply 94 times 11. And I always encourage you, after you have done your work, done all your problems, and done the trick with your boxes, I encourage you to draw the boxes, your ones, tens, hundreds, and if you need them, thousands place boxes, and then your multiplication work, I always encourage you to go back and double check on a calculator. And if you've come up with a different answer and you don't understand how, go ahead and raise your hand, and we'll get it worked out how to get the problem to work. So let's go ahead and get started with our worksheets for the 11 trick. And if you still haven't finished your lattice algorithm worksheets, we'll go ahead and get those worked on too. And when we're done with this,